Hello everyone, I'm Nkere-Awaji and today I'll be walking you through the student service within our SESC Student Management Microservice Suite. The student service has the following functionality. Um, ability The student service handles authentication, profile management, course viewings, enrollment, and graduation eligibility. And the student service also integrates with the library microservice and the finance microservice. This entire application stack would be orchestrated using Docker Compose, um, and would be interfacing with our Compose files using a make command. And our architecture is as follows. I would quickly show what our infrastructure diagram looks like at the moment here. So we have set up two networks, one for our entire application infrastructure and the other for our application suite. So for infra, we have our first proxy, our service discovery client, which will be using console. Our database is also part of an infrastructure network. Um, and yeah, our services are deployed on in the AppNet. We Here's also our development infrastructure for app and therefore our infrastructure seen here. Each of these have their respective environment variables. This env is like the general env4 that's being accessed that's being used by the compose files in this Docker Compose directory, and the finance library and student individual environment variables for the individual app services. Here's our make interface. And so the major things that concerns us here would be build, our down command, our make app command, and make infrastructure command. So let's go ahead and make and build our application stack. Okay, our application stack is built in. So we would make our infrastructure, make our application suite, application service suite. All good. So we can see here all our services are up and running. API gateway, finance service with its respective databases, our reverse proxy, and yeah, we have our entire application suite up and running now. So before I go into the demo, I would like to quickly show the ERD for our that shows the entity relationship between between the entities that make up the student service. Here we have our users entity, which houses our users information. So we abstracted the users away from the students away from the users, so we could not have multiple users for this platform. So for future basically making the platform and this student type is extensible. So we could have admins and other user profiles or roles. So this is a one-to-one relationship here, and here we have many-to-many relationship between the student and the courses, which is joined together with the enrollment table, which signifies the relationship between students and courses. Okay, so I'll take you through the entire app now. So first things first, we would like to log in. So I'll log in as me. Yeah. So auto login has been implemented here, so I don't exactly have to call in login to get access tokens. And we would like to fetch our courses, so we really don't have to pass an auth for fetching courses. This is an open endpoint. Then here we see our course details that has already been seeded. How did we seed this? We handle our database migrations using Flyway. So this takes care of all our database migrations. So here is where we seed our database, and on initial application startup, this automatically runs all the migrations one after the other, so they are run synchronously, following this particular order seen here: 1, 2, 3, 4 down to 6. Okay. So at this point, I would enroll into a course, and as part of the requirement for enrollment, once a user enrolls, we want to create an invoice on the finance microservice for that particular enrollment. So here we want to enroll into the artificial intelligence course. Okay, I see. Definitely passing a wrong token. So I'll get the right token here. Yeah, so gotten the right token, and this user has now enrolled successfully this course. Yeah, so we'll now fetch my profile. I've seen here my student ID. All right, so I will now update my first name and my last name as Nkere-Awaji. Just work successfully, and I also want to check the courses I've been enrolled in. So I've only enrolled in one course, the artificial intelligence course, and I want to check my eligibility for graduation. I'm obviously ineligible for graduation because I have a pending invoice, as we can see when we check all invoices here. I have this as my user ID, or my student ID rather. So by the time I check here, I see this student ID, same. So that's why I obviously can't graduate. So I would go ahead and pay that invoice now. So here I would pass in that and pay. So now when I check my eligibility, I should be able to graduate. So for the other requirements for when a book is returned late, a fine is issued and sent to the finance microservice to create an invoice. Okay, so we'll go to our web page now and we will access our API gateway. So our API gateway is deployed on port 300. The library is on 8082. So that's a student ID. For a new user, PIN is zeros. One, two, three, four, five, six zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So I check my account. Don't have anything, and yeah, I'll borrow. So you see here, I have borrowed up until this. So what I implemented here was just so that we can test, late returns automatically with each time. I backdated the borrow dates for about 14 days. So if we see here in the so I did this for 20 days. So replaced today, which came with the original service to a while ago. And yeah, so that we can test late returns and fines. So now automatically this when I return this, I get the fine, and obviously by the time I also go to check my graduation eligibility, I'm eligible to graduate because I have pending invoices. So this is for the enrollment, and this is for the library fine here. So I'll take care of my enrollment fees here. This has been paid, but I should still not be able to graduate, which is still true. And by the time I take care of the library fines, yeah, I'm good to graduate. So yeah, that's the typical flow. For my testing strategy, I make use of integration tests and unit test as seen here. Let me go to my tests, service and controller. So here we make use of the test containers, and here we make use of regular integration test going from and for other test cases as well. For as part of an improvement for this particular service, would implement a shared test container class where all other controllers can actually inherit from. But to show running test, We'll go into our student service, and we can run the auth service test. We can also run the auth controller test, which uses test containers as seen here. Can also run the enrollment controller test. Or even the course controller test. So I think we get the point by this profile, and we can run all those tests. So this is what a typical integration test looks like. We arrange, basically get our data, we seed our data, we act as we make an call to our endpoint, and then we assert. And basically this verify that the courses that we are getting matches the courses that we seeded our database with. And that's it for our testing strategy for our microservice architecture again. This was implemented using Spring API Gateway. So let me take you through our configurations. Okay, here, so we see we set up with all the register console service, basically register service for service discovery on console. So if we check here, we see all our services are up. This helps us basically verify service uptime. We are also implementing host routing using a reverse proxy called traffic, as seen in our networking diagram here. Traffic reverse proxy, which we can access on port. Dashboard is on port 80. 8080. So can go to 8080. And to check our routers, and we can see our different route hosts for finance local, library local, and students local. This helps us to actually reach our services using host names. So have that functionality turned off because there is some sort of clash gateway config. So that's what's seen here. We have a load balancing URL set up. So we have the load balancer configured for this API gateway already, and for each path. So for when we call / finance / libraries / students, we get routed to the appropriate services as seen already in request that was demoed. So for instance here, you can see our gateway host, which is localhost 300, our student path, which is this / this. And for invoice, you see our gateway host, finance path, and invoices. And for library as well, once we go to our library clients in the student service, we see we are referencing library using / library, and we are also making sure to call the gateway from our student service as seen in our YAML file. So and students gateway URL. This is internal, service name, and we're passing environment variables. So speaking of environment variables, so that's one thing that we made sure to make use of. As part of the 12 factor app rules, we are supposed to use environment variables for secrets or things or information that will be sensitive, or for hiding sensitive information. So also traffic for reverse proxy. This is where we define our host routing. So we are basically saying we are passing all our host routing to the API gateway, which will then reroute this request. So to demo this, I would quickly rebuild our app suite so that we can see how this works. That also shows the flexibility that comes with having our infrastructure and our app decentralized in Docker, so we can easily tear down and tear up independent service suites without tearing down an entire application. So our API gateway is in our app, so we'll just quickly rebuild our app. We make app. And here we see in console our services starting up slowly. Our API gateway is getting registered. Student service also. Student service is registered. API gateway registered. Student service is registered. All services registered and discovered. So we can go ahead and do something like this. So for instance, I can call finance to local. And I can search for invoices, pay invoices, find another invoice. I can also call library to local. I can use the admin endpoints 1, 2, 3, 4, 5, 6. See, can also call students to local. So say I did something along the lines of here say I did, for instance, list and road courses. I did something like this. Students to local. Students, rather. That's the name of our host. Obviously, why is this forbidden? this is for signed in enrollment. So to list courses rather, I can do something along the lines of, so since we're not using our gateway for here, I can do something along the lines of hosts and have host as that. So call courses. This is forbidden still. Okay, so this is slash API slash courses. Yeah. So once we call students local slash courses, so we can just make this slash API. All right, so yeah, that no, we didn't have to tear down our infra. We just had to rebuild our app, and we are good. Am I missing anything? Yeah, for future improvements, I had listed out a few improvements here on our repository. Here's our repository. Contains quick info concerning our services, our infrastructure diagram, how to set up a service. Yeah, so I had implemented the use of AMQP, which is Advanced Messaging Queuing Protocol, which would help us implement event-driven architecture. So, in situations where services are down, and for instance, we want to send a request to library and finance to create a new service, and we are relying on HTTP synchronous calls. If those services are down, we might have a breakage in our entire flow, and yeah, that basically causes us to be almost dependent on the availability or the uptime of other services for certain actions that our individual services would need to take. So if we have an event-driven architecture, then we can always have messages replay that, and when the services come back up, we can always replay those messages and have those services attend to those messages. That way we can ensure that each system and each service actually each service is while they are dependent on each other to actually form the entire application suite. They are also standalone services, and they're actually autonomous that can run individually without having to break because of the inavailability of other supporting services in the entire microservice application suite. For better observability and resilience, we would also implement Prometheus and Grafana dashboards. We would need to also implement CI/CD for when we actually deploy this service to the cloud environment for access, basically for public use, to ensure that to make the process of building and also packaging and deploying a lot streamlined, with just push to specific branches, code will get deployed instantly. Also, one thing that we've added here is our documentation for the student service. So slash let me reference this again. Yeah, so we implemented open API documentation for our service. Students, I always mix this up every single time. Shortly after this, I would also, show where this was actually defined. So yeah, this contains all our endpoints, our authentication endpoints, our enrollment, profile management courses, properly documented. So for users or people who need to interface with this service, we do not have something that they can actually reference. This also contains our schemas, and for our host config that lives in our etc host. For Linux, I think also, yeah, Linux, yeah, and Linux-based operating systems. This lives in etc/host. This is where we define our library, local, finance, and yeah, students should probably change this back to students. But yeah, that's all for now. Thank you for your time. Please feel free to go through the code base, the documentation also, and yeah, let me know if there are any questions. Thank you.